In our last video, we were introduced to the ideas in the mean value theorem by drawing a picture together. The mean value theorem says, if y equals f of x is continuous over the closed interval ab and differentiable on the open interval ab, then there's at least one value c on the open interval ab so that f prime of c is equal to f of b minus f of a all over b minus a. The instantaneous rate of change at some value c is equal to the average rate of change over the interval. Another way to think about it is, like in our diagram, there's a tangent line that's parallel to the secant line for at least one value, maybe more. But the whole idea is that at some moment, the instantaneous rate of change is equal to the average rate of change. Imagine that you were sitting in a car on a long straight highway, and that you started from a stop at 0 miles an hour, and then you accelerated for a while, and then you stopped the car again. Let's just say your average rate of change was 60 miles per hour. The mean value theorem tells me that at some moment you were actually traveling at exactly 60 miles per hour. That at some moment your instantaneous rate of change was equal to your average rate of change. Well, let's use the mean value theorem with a particular function to work an example. I want to start with problem number 4 on page 235. The instructions here. Find the value or values of c that satisfy the equation f of b minus f of a all over b minus a equals f prime of c in the conclusion of the mean value theorem for the functions and intervals given. So in problem number 4, we're given the square root of x minus 1 over the interval 1, 3. So we're asked to find the value or values where the instantaneous rate of change is equal to the average rate of change on this closed interval. So I think we should start by actually finding that average rate of change. So I need to evaluate f of 3 minus f of 1 all over 3 minus 1. All right, well, f of 3 minus 1 is 2, so that's the square root of 2. And then 1 minus 1 is 0. So my average rate of change is the square root of 2 over 2. Now, what I'm looking for is a value c so that f prime of c is that number, root 2 over 2. So I need to solve an equation. I need to take the derivative and see if I can find where that x value is that gives me this slope. So what I'm really doing is looking for a value of c where I have a particular slope. So let's take a derivative and then see if we can find that value c. All right, so I'm thinking about that square root as a 1/2 power. And I need to take the derivative of the inside, but that's boring here. It's just times 1. And so my derivative is 1 over 2 square root of x minus 1. So now I'm thinking about what value do I plug in there so that this is equal to root 2 over 2. So let's set the two things equal to each other and see if we can solve that equation. So root 2 over 2 is equal to 1 over 2 root x minus 1. All right, let's move on over to the next board and see if I can finish solving this equation. All right, well, I'm going to solve this equation by multiplying both sides by 2 times the square root of x minus 1. On this side, the over 2 and that 2 and that 2 would cancel, leaving me with this. And on this side, I would just be left with 1. All right, so now I need to work on getting the x by itself, and I could go on and square both sides, but I'm going to isolate the radical that I really care about. And now I'll square both sides. And then finally, I would find out that x is equal to 5/4. the value c, where f prime of c is equal to f of 3 minus f of 1 all over 3 minus 1. That moment that satisfies the mean value theorem is 5/4. Now, one thing we should always check, the value I get is supposed to be between the values of a and b. 5/4, 1.25 is between 1 and 3. The reason I mention that is maybe we got 3 or 4 answers to this. We want to make sure they live on the right interval. All right, so the moment this function's average rate of change is equal to its instantaneous rate of change is at 5/4.